Question 8 then from paper 1 of the 2023 Advanced Higher Maths proofs, just the 3 marks, so it's in 2 parts. The first part says, find a counterexample. Consider this statement. If a and b are integers and a is less than b, then a squared is less than b squared. Find a counterexample, just for the 1 mark. Well, it's going to be about negatives then, isn't it, with these integers? So just make sure you choose a to be a negative big number. The numerical part being bigger than b, so just make b 1 for instance. Because certainly if you choose them, then a is less than b. Negative 4 is further back than b. But a squared jumps up to 16, but b is just 1. Now a squared isn't less than b squared. So there's a counterexample, that's disproved it, so the whole pack of cards falls. Right, now we just have to write out the big sentence. The statement is false by counterexample a equals negative 4, b equals 1. Now part B, let n be an odd integer. Prove this time, prove directly that n squared minus 1 is divisible by 4. Well, express n in such a form that demonstrates it's odd. So if you say let n equal, now 2k would have to be even, so either plus 1 or minus 1. I'm going to go for plus 1. You have to watch what kind of numbers you're using though, because a plus 1, if you're only using positive integers, can't produce a 1. Then you'd go for 2k minus 1, but it makes no difference here because it's all the integers. Where k is an integer. Well, that means that n squared minus 1 will equal 2k plus 1 squared minus 1. So that will be square the bracket now, square the first, twice the product, square the last. See, this wouldn't make any difference because if we put a minus 1, it'd still be a plus 1 there, which gives you, wasn't going to write this out, which means you've got a common factor, but you're only interested in demonstrating a common factor of 4, so I'll leave those bits together, which equals a multiple of 4. Since k squared plus k will also be an integer, which means that, now you can make your statement, n squared minus 1 is divisible by 4. Maybe I should put where n is an odd integer. And so to number 9 then, it's only 4 marks, but there's lots of little bits and pieces here. Probably won't like this, these transformational matrices. State the matrix associated with an anti-clockwise, that's the direction you do it in anyway, rotation of pi upon 2 radians. Well, you get that at the front, what they're saying, call this A. That's that little 2 by 2 matrix that goes cos theta, sine theta, and then negative sine theta, cos theta. So it's just that when theta is equal to pi upon 2. So that means that A is going to be, just feed those numbers in. So those are the 90s then. So cos of 90 is 0, sine of 90 is 1, and that'll be negative 1, and that'll be 0. Now what does it say? The matrix B is given by this, so that's another rotational matrix. You can just quickly figure out what that is here. Because you can see that's the sine, so that's a 30 degrees. And it's where the sine is negative and the cosine is negative. So that's down here then. So this represents a rotation of that amount. So that's 30, so that's going to be 210 degrees. Didn't ask for that though. But it says determine AB. Oh well. AB is a composition of transformations, which means carry out B first, which is rotate at 210, then follow it with A, which is rotate it by 90. So that's going to take you to 300. So your final result, which will probably be later on, will be here, will be a matrix that rotates it by 300. So AB is going to be, but you have to multiply it out, times negative root 3 upon 2, a half, negative a half, negative root 3 upon 2. So, but at least there's zeros there. None of them, minus one of them, so that's a half. None of them, minus one of them, so that's root 3 upon 2. One of them, negative root 3 upon 2. One of them, lost place in none of them. One of them, a half. That was part 1. 2, so 2. That represents a anti-clockwise rotation of, it just says determine, you know what it is, it's 300. But we'll have to do it in radians probably. So if that's 300, well, you could get it, maybe you could show some working, because you know that's the cosine. I'll just put it down. You know that the cosine of this angle is a half, and that the sine of this angle is negative root 3 upon 2. Then you could just, I'll put it down here, all sine, tan, cos. Positive cosine, negative sine. So that puts you in the fourth quadrant. You know what the answer is coming up. So and you know that the angle is a 60 degrees, so it's 60 degrees there, so it's 300. So that means that alpha would have to be, but put 300 into radians, I think. I don't see what's wrong with 300 though. That's going to be 5 pi upon 3. Determine the least positive integer value of n such that ab to the power n equals I, the identity matrix, just for the 1 mark. Well, that just means AB is that rotation, that composition is that rotation of 300 degrees. How many times would you have to keep rotating by 300 degrees until you got back to where you started? In other words, I'll set it out formally, n times 5 pi upon 3 would have to be some multiple of 2 pi, because every 2 pi takes you back to where you start. So what's the first value of n that will produce a multiple of 2 pi? It would have to be either 3, which isn't enough because that's 5 pi, so it'll have to be 6. N is 6.